Yes, good morning. So today we are going to discuss about fourth unit. The fourth, what is third unit? Title of the third unit: dynamic programming. Can anyone say the applications of dynamic programming? Traveling salesperson problem, all page short path problem, knapsack problem, multi-stage, right? Knapsack problem. There are two knapsack problems: general principle and one is binary. Binary means 0 by 1 knapsack problem. So those are what is the use for which type of problems we will use a dynamic approach. A problem which is of type so and so. So depends upon the problem we apply different techniques. As in the first problems. Good morning, ma'am. ఓకే అవునంట నేను అక్కడ వచ్చారంట వీళ్ళు అక్కడ చెప్పాను అక్కడ 3-4 కూడా చెప్పిన మరి నెక్స్ట్ టైం వచ్చినప్పుడు అవునా ఓకే మేబీ అవునా ఓకే ఓకే చెప్తాను చెప్తాను ఇప్పుడు ఫోర్త్ స్టార్ట్ చేస్తాను మేడం ఇవాళ ఫోర్త్ చేసేస్తాను రేపు కంప్లీట్గా ఫిఫ్త్ అయిపోతుంది అందుకే మేడం ఇవాళ కొంచెం స్టార్టింగ్ కదా స్టార్టింగ్ ఈ ప్రాబ్లమ్స్ అటెన్షన్ ఫిఫ్త్ యూనిట్ రేపు తక్కువ టైం అవసరము కానీ అది నేను చెప్పేస్తాను మేడం స్థిరం అవన్నీ చెప్పేస్తాను ఎన్పీ కంప్లీట్ అవన్నీ చెప్పేస్తాను ట్రావెలింగ్ సేల్స్ పర్సన్ ఆప్టిమల్ బైనరీ సెర్చ్ కావాలా మ్యామ్ ఆప్టిమల్ బైనరీ సెర్చ్ థర్డ్ యూనిట్ అదే అడిగాను ఇందాక థర్డ్ యూనిట్ ఏమన్నా కావాలని మీకు ఇంకేమన్నా ఉంటే థర్డ్ యూనిట్ చెప్పండి ఇప్పుడైతే ఫోర్త్ స్టార్ట్ చేస్తాను అని చెప్పాను ఆప్టిమల్ బైనరీ సెర్చ్ చెప్తాను మ్యామ్ అది కూడా చెప్పేస్తాను షూర్ షూర్ మ్యామ్ ఓకే మ్యామ్ మ్యామ్ యా అమ్మ పెన్ మీరు 4 ఇక్కడ 5 అని ఉంది కదా అది వదిలే అకార్డింగ్ టు యువర్ సిలబస్ ఇట్ ఈస్ ఫోర్త్ యూనిట్ బ్యాక్ ట్రాకింగ్ ఫిఫ్త్ యూనిట్ కూడా చెప్తాను లేదు ఫస్ట్ ఇది చెప్తాను ఎందుకంటే ఫిఫ్త్ యూనిట్ చాలా తక్కువ టైం ఫిఫ్త్ యూనిట్ చెప్పేసరికి టైర్డ్ అయిపోతారు ఇది ఇంపార్టెంట్ కదా ఈ ప్రాబ్లమ్స్ ఉన్నాయి కదా నాప్సాక్ ప్రాబ్లం ఎన్కిన్ ప్రాబ్లం కాసేపు అయితే మనం స్టేట్ మారిపోతాం కదా కొంచెం డెలిగేట్ అయిపోతుంది మళ్ళీ చెప్పమన్నారు మరి కొన్నే కవర్ చేశారు కదా మళ్ళీ చెప్పమన్నారు అన్నీ చెప్పారు ఫిఫ్త్ యూనిట్ కూడా చెప్తాను 2 days టైం థర్డ్ యూనిట్లో కూడా కొన్ని టాపిక్స్ కావాలన్నారు ఆప్టిమల్ బైనరీ సెర్చ్ చెప్పారా చెప్పలేను మేడం ఆప్టిమల్ బైనరీ సెర్చ్ చెప్పలేదు అది కూడా చెప్తాను అదే అంటున్నా ఫిఫ్త్ కాకుండా 1 to 3లో మీకు ఏదైనా స్పెసిఫిక్ ఉంటే కూడా చెప్పండి కవర్ ఇట్ చెప్తాను ఫిఫ్త్ యూనిట్ చిన్నదమ్మా వెరీ స్మాల్ అలా కాన్సెప్ట్ ఏమీ లేదు చిన్న టాపిక్ వెరీ స్టార్టింగ్ రేపు మార్నింగ్ ఫస్ట్ అవర్ చెప్పేసి ఫస్ట్ అవర్ కూడా లేదు తొందర అయిపోద్ది రైట్ సో ఫర్ విచ్ టైప్ ఆఫ్ ప్రాబ్లమ్స్ the technique which is dynamic programming will apply decision making. So normally for complex problems we need to write an algorithm. For such a complex problems can be divided into different categories. Complex problem is able to divide into number of subproblems, then we'll go the approach as which technique? A problem which is can be divided into subproblems. Each subproblems all individually combined as a solution as a one single solution. Then that is which technique? Dynamic. Problem P1 is there. So we thought that the problem P is a very complex. At one stage we cannot able to solve. Then what we have to do? This problem can be divided into subproblems P1, P2, P3. P1 you separately you have to solve as it is it is not very length. Then P2 separate, P3 separate, and P4 separate. All the solutions as a combined one single solution. Then that is the technique called as divide and conquer problem. All the complex problems cannot be applied as a one single method. So all the problems divide and conquer problem technique is not able to suitable. Then after this divide and conquer problem, then a problem P is complex but which is not able to divide into subproblems. Then such a problems they apply a technique called as which is not able to divide. Greedy. So what is the greedy method? What is the output of greedy method? Applications of greedy knapsack. Greedy knapsack. What is the aim of this knapsack problem? Finding shortest path problem. Min and max. Min and max is divide and conquer. So what is the aim of this knapsack problem? There is a greedy method can be applied for the knapsack problem. Maximize the profit. So the intention is to get maximum profit. That is, you can say optimal solution. What is an optimum value? Optimum solution gives. What is the optimization? Optimization means optimization is not always is nothing but minimized. Optimum is nothing but you'll find a best solution. Best with respect to your choice. Your choice is to get a maximum profit, then it is optimal solution is a maximum profit. Then your choice to get with a minimum distance. If your problem is to travel from one place to another place, then obviously you are expecting that distance should be with minimum. There are number of possible ways. Among the possible ways, we are always try to select a minimum distance path. So these two types of problems, greedy can be applicable, but what greedy says that it is gives an optimum solution. That solution may be minimum or it may be maximum. Minimum if your problem is that to find the distance. Maximum you have to get a maximum profit if it is a profit. Right? Dynamic programming. Dynamic program also will get also all the solutions and applied, but there is a technique which is applied. Dynamic application, dynamic programming applications, all pair shortest path problem. There also zero knapsack. The difference is that the problem in the knapsack problem, in the previous greedy approach, if an item, so depends upon the bag size, so we'll place into the bag. Before placing into the item into the bag, make sure that the bag should have enough space. If you are selecting item weight is n units, 10 units for example, the leftover space in the bag is only 8 units. Hello. So selecting an item weight is 10 units, whereas the bag capacity, leftover capacity is only 9 units. So we cannot place into the complete item into the bag. Then it is a provision. Twelve to 1 break. What? अच्छा,
డిస్టర్బెన్స్ లేకుండా వెళ్ళి రావడం కన్నా 1 అవర్లో వాళ్ళు లంచ్ చేసి మిగతా వర్క్స్ అన్ని చేసేసుకుంటారు. మళ్ళీ 1:15కి మీకు ఇక్కడికి వచ్చేయండి సార్, వాళ్ళు వచ్చేస్తారు.
Okay. So then leftover space is not enough to place an item. In that case, there is a provision that you can break the item, whatever the part you wish to place into the bag. So 10 kgs you can break into two parts. One is 9 kgs, one is 1 kg. Then you just leave that 1 kg of item, and remaining 9 kgs you place into the bag. Whereas 0 by 1 knapsack, it is not that is not allowed. 0 by 1 indicates that the item, 0 indicates that item is not selected. 1 is item selected. If you wish to enter, if you wish to place the bag into item into the bag capacity must be greater than or equal to the size of the item. And here breaking of item is not possible because all the items may not be possible to break. Generally, knapsack problem, enti, the intention of the knapsack problem generalized, we can say that మన ఇంట్లో జరిగే దొంగతనం, ఎవడు వచ్చాడు అనుకోండి థీఫ్, ఐటమ్ తీసుకెళ్ళాలి, వాడి ఇంటెన్షన్ ఏంటి, మ్యాక్సిమం ప్రాఫిట్ వచ్చే ఐటమ్ తీసుకెళ్ళాలి ఇన్ జనరల్. సో అలానే ఒక పెద్ద మీ దగ్గర ప్లాస్మా టీవీ ఉంది అనుకోండి, 55 inches ప్లాస్మా టీవీ, 81 inches ప్లాస్మా టీవీ ఉంది, రైట్, దెర్ ఈస్ ఎ కాస్ట్ ఆఫ్ 2 lakhs. There is one more item, just only 10 grams of gold, పక్కనే ఉంది ఇంకోటి, 10 grams of gold, only 1 lakh. That is the cost of item which is plasma TVs, 2 lakhs. So profit maximum రావాలి కాబట్టి he cannot select that item. ఎందుకు? He is not able to carry. For carrying 10 grams of gold is where compared to the profit, less profit. అలాని టీవీ తీసుకోలేడు. So he himself has a carrying of 5 kgs of item అనుకోండి. So he cannot break that item. అదే ప్లాస్మా టీవీని బ్రేక్ చేసి తీసుకోపోయాడు అనుకో, no use. So such that 0 by 1 indicates such a problems. If you want to take it, take complete item, otherwise just leave it 0, or you take it complete item 1, 0 by 1 knapsack. So next we can say it is one more technique, that is the fourth technique, backtracking. Normally what is backtracking? Backtracking is nothing but, for example, there is one source, among these multiple paths are there. So this D is a destination. Your intention is to travel from source S to D. S to D. So when you are here, then you don't know that which is the correct path. There are multiple 1, 2, 3, 4 alternatives. We don't know which is exactly correct way or correct path to reach a destination. Then obviously what will do that, here if it is randomly you have chosen this path. Assume that just we are expecting this may leads to our destination. Then you have to travel from here to here. For example, next station is 1 and 1 2, there is no alternative, you must travel from 1 to 2. At 2 again there are two options. In this case you have chosen this one. Two alternatives low, randomly I have chosen this path. Then at station 3 there are no more further ways and it is a destination usually, but my target is not to reach a station 3. His intention is to reach D. Then you are realized here and assume that, so I have chosen the just before station, there are two alternatives, then the chosen alternative is wrong, this is not the correct way. So then you go back to the only one station, go back to only one station, is called backtracking. Moving back to the one step back, moving back to the one step, that is called backtracking. When it is K2, then again you have to go with the other alternative. There are two, one is already decided which is wrong, then go with this path, and again you are at station 4. There again it is two alternatives, then randomly you have chosen, assume that the year, then it is station 5 and which is not your destination. Then again you have decided that this is not my destination, go back, then this is called a backtracking again. Here you have chosen this one. Then this is the path you have selected. It is final destination. So what happens at here? There are multiple solutions are there. Among the multiple solutions, only one solution or two, three are solutions are correct. But choosing that particular solution is not possible at one single step. If it is your alternative is wrong, then there is a provision to go back to the previous step and change your decision. You have been changed your decision here. It is not this way and go to this decision. There is a provision to change your decision. That decision is allowed that backtracking process. Backtracking. The application of backtracking. So before this backtracking, and it is also it is not giving the solution optimal solution. It is not giving optimal solution. It gives all the possible solutions. Among that best one it is selected. All the possible solutions. Whereas among all the possible solutions, we need to follow some constraint. So we'll impose the problem. All the solutions are given. Among the solutions, based upon the criterion, based upon the a condition, based upon this condition, a criterion is called as bounding function. Based upon this bounding conditions, we'll select one is a minimum one or one is the best solution. For example, there are two boys. There are two boys and one girl. The intention is to arrange. There are three chairs. There are three chairs. Just provide a seats for each student as one seat. Question is that just arrange three seats for three students. On that three students, two boys and one girl. So what we'll do generally, first boy one, then boy two, then girl. This is one way. And someone is arranged like this. B1, B2. There are number of ways we can allocate. So usually we can say how many ways? Three factorial ways we can arrange. N equals to 3, that is 6 times, 6 ways. We'll arrange in a 6 ways. But the same 6 ways we can represent here in the tree structure. For example, see here. First boy, the chair, first chair. And the second chair is allocated for boy 2. Third chair is allocated for girl 1. Chair 1, 2, 3. But here, make sure that branch and backtracking follows a technique which is called depth first search. What is depth first search? Graph traversals, tree traversals. Gurtunaya? DFS and one more thing. What is B? Breadth first search. Right? So this backtracking follows DFS. One more technique which is there, but according to syllabus it is not there. The technique called as branch and bound. Branch and bound. This branch and bound follows breadth first search. We'll see what is DFS. DFS is depth first. So it is in the depth order. First chair 1 for the boys 1, chair 2 in the depth allocated for the boy 2, chair 3 and below this it is for a girl. Depth first. And again your decision is changed. One more alternate also we can do. So first boy 1, boy 2, girl 1. So here you have changed that. No, it is in the third place. This is third place. In the second place, not boy 2, girl. So what happens in the second place, it is not boy 2. We can also arrange girl. But how can we decide? So after this place, after the first allotment, then you have decided here. No, I don't want to be girl is the last place. Then I want to place a chair, allocate a chair for the girl at second place. This is chair 1, chair 2, chair 3, for example. Just assume that this chair. And chair 3 is allocated now. Listen. So my decision is changing to chair 2 for the girl. Then I have to go back to the chair 2 from chair 3 to chair 3. So here it is backtracking. using backtracking. And here not B2 for girl also. Means that after this first allocation of chair for the boy, chair 2 can we have an option to allocate either boy 2 or a girl. There are two options. Any one you can choose is correct. Means that here we can say, so if this is the path you have selected, what is the process? B1, B2 girl. Means that this one, B1, B2 girl. And you have chosen path is B1, then it is girl, the second position. This is the third place. To whom you need to allocate? Boy. This is the third chair for the boy two. One more solution. So here, second place in the girl. Then here in the second place. No, no, it is boy two is not third chair. I want to make it second chair. It is already there. Then go back to this station and chair one. I want to change it. Chair one. I want to allocate for the girl. First chair. And the second option, second chair. It may be boy one. If it is boy one, obviously this is for boy two. But there is an option at second chair. You can allocate either boy 2 or boy 1. Then you can say here boy 2 no need allocation. Here I can have an option for the same. It is B2. This is called backtracking. So here this is an option. First girl boy 1 second, then boy 2. First girl boy 2 second, then girl for the third chair. One more option. Then first itself boy 2. First chair. This is the first chair one. Then my decision is to allocate boy 2 for the second chair. Obviously, for the third chair, it is allocated for the girl. No, I don't want to be here, girl. Girl should be in a second chair. Then here, go back, and here it is girl for the second chair. Then obviously third chair it is ఎక్కడమ్మా ఎక్కడమ్మా here 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 it is boy 1. Here it is boy 1. So here in this case a girl and again boy 2 already there. It is boy 1. Then how many it is? 1, 2, 3, 4, 5, 6. 6 ways. All these are the possible ways. The 3 members, 3 chairs unte. These are the 6 ways we can allocate. Conditions same leave. Then there is one condition which is imposed. Arrange 3 chairs for the 2 boy and 1 girl such that no girl sit in middle of the boys. No girl is allowed to sit middle of the 2 boys. Girl ఎక్కడ కూడా మధ్యలో ఉండదు. See here, if you have chosen this path, if you have chosen this is the one path, that is first B1, B2, girl is the last, and second one B1, B2, not B2. It is then first chair B1, second chair it is for girl, next third chair for B2. And this way, the first it is girl, and for B1 it is second chair, B2 for third. And next first girl, next it is B2, next it is B1. Here, B2 is the first one, B1 and a girl. Sorry, B2. Then it is B2, girl, and it is B1. There are 6 possibilities. 1, 2, 3, 4, 5, 6. See, among these, how many possibilities? A girl is sit in the middle such that the girls should not sit in possibility. Then we are removing the second one. Second one is nothing but here. Whenever the first the boy one, and you try to allocate for the second seat for the girl, then here it is remove this one. No need to allocate immediately. Whenever it is second chair is allocated for the girl, immediately we can say that the condition is that girl should not be in the middle of two boys. Then we can say it is wrong. That is block it here. So don't extend, don't see the next possibility, don't allocate the next change for the next person. This is unnecessarily. Here itself I can say this combination is not allowed. After this only here you can say it is whoever will allocate it for the next chair least bothered. Here itself we can say that this is not a solution. How can we say that this is not a solution? That is based on your constraint. You have given a condition that arrange it is for 3 boys and 3 girls such that there is a condition. So based on that condition, I can say this is not a solution. And next one here, this last solution. First boy 2, when it is second chair, here it is allocated immediately without extending this part. Without extending this part, we can say it is a block. So kill here, kill the node here itself and don't extend here, and remaining are the possibilities of according to your constraint. Constraint is no girl sit in the middle of a 2 boys, or if the constraint is that no boy one, particularly we are saying that no b1 is sitting at the last with the constraint, no b1 is allowed at the last, then your solution may be changed. This is not, these two solutions, these two are should be removed based on the constraint. So from this I want to say that a backtracking allows that all the possible solutions, design solutions, among all the solutions based upon the conditions imposed on that problem. Some solutions are no need to extend based on the condition itself. Without calculating further steps, we can stop the solution there itself and announce that this is not a valid solution. అన్ని పాసిబిలిటీస్ ఫైండ్ అవుట్ చేయాల్సిన అవసరం లేదు. వెరస్ నాప్సాక్లో ఆర్ షార్టెస్ట్ బాల్లో అన్ని చూసి మినిమం, రైట్? హియర్ all the solutions, here itself we can say that it is not a possible to extend. అక్కడ అవసరం లేదు, ఇంకా అక్కడికే చెప్పేస్తాం. So that is a bounding function. That such a conditions we can say that bounding function or criterion we can say. That criterion function are two types of criterions again. ఏంటవి two types of criterions? Implicit constraint and explicit constraint. There are two constraints, implicit and explicit constraint. Based on these two conditions or constraints, we'll solve the given problem to find a solution. Applications of backtracking. So every solution of this backtracking, every solution will be represented in the form of a tree called as state space tree, right? So in the state space tree, before going to discuss this state space tree, we should know some terminology. What is criterion? And also live node, dead node, e node. There's any definitions. So just make a note of these definitions. Then we'll go to construct a state space tree for the application of backtracking. So first write down the backtracking heading. In backtracking, all right, here it is DFS. So we have forgot BFS. Here it is DFS approach. If you want to follow this BFS to arrange 3 chairs for the 3 users, the users, there is no constraint. For example, no constraint. No constraints itself, this is a diagram, no? If it is BFS you want to construct, first chair itself, there is an option. Boy 1 may sit, girl may be sit, or boy 2. First chair itself, depth first, it is decided in the depth manner. Here breadth first, the level wise. This first time itself we are deciding that in this level wise. it is B1 or girl B2. So first chair, second chair, third chair. In the first case itself, 1, 2, 3. In this level only, 1, 2, 3 chairs are decided. Right. Next one. If it is first, second chair, next maybe it is boy 2 or it is girl. It may be girl. And next again it is for B1 or it may be a B2. Again it is B1 or a girl. For example, if it is the second chair, this is a place. Next again it is only the possibility here, B2. Only the possibility here, only here possibility B1. Only here girl. Only here possibility B1. So this is a depth level you are deciding. This is BFS. That is approach we are following actually branch and bound. That is not there. We don't discuss that branch and bound. Just you should aware of that. In design and of algorithms, design analysis of algorithm, there is a method divide and conquer, greedy approach, dynamic programming, backtracking, and also branch and bound. One more branch and bound also, right? Just to make a note here, this technique we are following, we are arranging in three factorial ways for three users, three chairs, right? 6 ways. 6 ways we are calculating based on the conditions. We'll omit some solutions because that solution is not relevant based on this condition. So this is the approach we can say it is a brute force approach. This approach we can say brute force approach. Means maybe shortcut లో ఎక్కడైనా ఆబ్జెక్టివ్ అడగచ్చు. బ్యాక్ ట్రాకింగ్ అలో ఫాలోయింగ్ విచ్ అప్రోచ్ యాజ్ బ్రూట్ ఫోర్స్. బ్రూట్ ఫోర్స్ అంటే ఏంది? ఆల్ ద పాసిబిలిటీస్ అన్ని ఫైండ్ అవుట్ చేయాలి. ఆల్ ద పాసిబిలిటీస్ ఫైండ్ చేసే ముందు జనరలీ ద సొల్యూషన్ ఆఫ్ బ్రూట్ ఫోర్స్ ఇస్ గివ్స్ ఆల్ ద పాసిబిలిటీస్. బట్ బ్యాక్ ట్రాకింగ్ ఇంపోజ్ చేసినప్పుడు, కండిషన్ అప్లై చేసినప్పుడు ఆల్ ద పాసిబిలిటీస్లో ఫ్యూ ఆఫ్ ద పాసిబిలిటీస్ వీ కెన్ నోమిట్ డైరెక్ట్లీ. బ్రూట్ ఫోర్సే ఫాలో అవుతున్నాం, బట్ కండిషన్ బట్టి ఆ సొల్యూషన్ని మనం ఇగ్నోర్ చేస్తున్నాం బికాస్ దట్ సొల్యూషన్ ఇస్ నాట్ రిలేటెడ్ బేస్డ్ ఆన్ దిస్ కండిషన్. సో ఇట్ ఈస్ సెయింగ్ దట్ బ్రూట్ ఫోర్స్ టెక్నిక్ is applied at a backtracking. So keep citing here. In backtracking, we'll use bounding functions or criterion functions. It uses brute force approach. Notes lo prati okati raskondi, and this notes is enough for your external exams. Note down every point in the class. That is enough. No need to see any videos and PDFs. Next one, the major advantage of backtracking. The major advantage of backtracking method is if a partial solution x1, x2, x3 and so on, xi, partial solution x1, x2, x3 and so on, xi can't leads to optimal solution, then xi plus 1 xi plus 1, xi plus 2, xi plus 3, and so on. Then xi plus 1, xi plus 2, and xi plus 3, and so on. Solutions may be ignored. Solutions may be ignored. Solutions may be ignored entirely. Solutions may be ignored entirely. Right. So means that first we'll try x1, x2, x3 as the solutions. So solution 1, x1 is not able to solve. Solution 2 will try it. This is also not sufficient. Some finite number of solutions we'll try to find. Those solutions are not suitable for your problem. Then simply we can say that remaining also there is a possibility to find remaining some solutions, but we won't do that and conclude that. So this is not possible to solve. That is xi వరకు ఫైండ్ చేసినాం. తర్వాత xi ప్లస్ 2 కూడా ఉన్నాయి. ఇంకా అనుకోకుండానే మనం చెప్పేస్తాం. సో ఇట్ ఈస్ సొల్యూషన్ ఫర్ దిస్. అంటే ఏంటి ఆప్టిమల్ సొల్యూషన్ ఫైండ్ అవుట్ చేస్తాం. బట్ ఆప్టిమల్ సొల్యూషన్ అన్నీ చేసి దాంట్లో బేస్ తీసుకోవాలి. దీంట్లో అన్నీ చేయాల్సిన అవసరం లేదు. దట్ ఈస్ అన్ని ఎందుకు చేయమంటే బేస్డ్ ఆన్ ద కండిషన్. నెక్స్ట్ సమ్ టెర్మినాలజీ యూజ్డ్ ఇన్ బ్యాక్ ట్రాకింగ్ మెథడ్. Some terminology used in backtracking method is the first one criterion function. కొంచెం ఫాస్ట్ గా రాయాలి. Deciding p of x1, x2, x3 and so on xn. It is a function p of x1, x2, x3, xn which needs to be maximized or minimized, for a given problem. Next heading, solution space. Next is heading number 2, solution space. All tuples tuples, all tuples that satisfy the explicit constraints define a possible solution space. For a particular instance I of the given problem. And note on this tree. A, B, C, and B will have again D and E. Solution space అంటే it takes the path. ఇందాక B1, G, B2, B1, B2, G. So here A, B, D is one solution space, I can say. So that is here A, B, D, A, B, E, A, B, E and A, C are the solution space. Next one, problem state. Third one, problem state. Each node in the tree organization Each node in the tree organization is a problem state. Each node in the tree organization is a problem state. So if it is a tree is like A will have B comma C, then each node, how many nodes here? 3. Then here each node A, node B, node C are the problem states. If this is a tree, note down this tree, below this write down here A comma B comma C are the problem states. Are the problem states. Are the problem states. Next, solution state. Solution states. These are those problems. These are those problem states. Those problem states capital S. Those problem states capital S. For which the path from the root to S, the path from root to capital S, root to capital S defines a tuple, defines a tuple in the solution space, in the solution space. So note down this tree. This is one. This is solution state, no? Right. Some nodes represent, there is a triangle inside. Some nodes circle, upon that there is a rectangle, or we can say square. What is solution state? Here, write down here square. Here square indicates solution. Square indicates solution. Square indicates solution. Right. For the above solution state, for the above solution space, there exist three solution states. There exist three solution states. Enti 1, 2, 4. ఏవైతే సర్కిల్లో ఉన్నాయో that is called one solution. Means that ఇందాక మనం six possibilities డ్రా చేసినాం. దానిలో 2 because those are not satisfied the constraint. Constraint between the two boys, there is no girl is allowed. That 2 are removed. Remaining 4 is valid. So you can say it is one whenever a square indicates that a solution. So we can say as a solution 1. This is solution 2, solution 3. So solution states are S1. What is the solution states? 1 comma 2 comma 4 is one solution, and second one is 1 comma 3 comma 6 and 1 comma 3 comma 7. There are solution states: 1 comma 2 comma 4, 1 comma 3 comma 6 and 1 comma 3 comma 7. Next heading, state space tree. This is the most important. So backtracking, all the solutions can be represented with a state space tree. State space tree. If we represent solution space in the form of a tree, solution space in the form of a tree, then the tree is referred to as solution space is represented in the form of a tree, then the tree is referred as a state space tree. State space tree. So one day, this is complete space tree. So in that only the solutions. So we put this. Then it is state space tree. Possible solutions tonight. Next heading, answer node. Answer states. Answer states. Solution states. These solution states capital S. Solution states capital S. These solution states capital S, which the path from the root node to S, capital S, from the root node to capital S defines a tuple, which is a member of the set of solutions, in bracket, write down in bracket, that is, it satisfies the implicit constraint. Bracket close. Implicit constraint, bracket close. That is, which is a member of the set of solutions of the problem. Bracket tarvata the problem. Solutions of the problem. Note down this one. Note down this tree. Note down this one. Here, node 3, comma node 4 are the answer states or answer nodes. 3, comma 4 the answer states. Solution states enti S1 S2 and solution states S1 comma 2 comma 4 and 1 comma 3 are the solution states. And 1 comma 2 comma 4, 1 comma 3 are the solution states. Ekkadaithe answer vasto that is called rectangle. The path is called solution state. Next side is live node, LIVE, live node. Write down a node which has been generated, a node which has been generated, a node which has been generated, and and all of whose children, and all of ALL, all of wave, all of whose children have not yet been generated, whose children have not yet been generated, not yet been generated, is called live node, is called live node. I'm going to note down this. This is one tree, I can say. Tree contain only one node, root. This is tree 1. For example, this is figure 1. One more figure, one more tree. This is and figure 3. Note on these 3. Live node and live is also which is generated. Where నుంచి generate అయ్యి ఉండాలి, but it does the starting node itself, which is not generated any children, not yet being generated any children. Figure A లో ఏంటి? Only one node, capital A. Capital A doesn't have any children. Then here in figure, after this write down in figure 1, node A is live node. Then in figure 2, live node is a node which is generated, but it doesn't have a children. A generated B and C, so which is generated. So A is not a live node. But B is a node which is generated from others, but B itself not having any children. Any children. And C also same. Figure 2, node B comma C are the live nodes. And figure 2, figure 3 లో B idunda B is not there because B is generated from others, and also B itself generated 2 more children. So B is not belongs to generated from other node, but C itself doesn't have any children. So C and D comma E are generated by the B, but D comma E doesn't have any children. C comma D comma E are the live nodes. Next, E node, capital E, E node. E node. The live nodes, the live nodes, the live nodes
whose children, the live nodes whose children are currently being generated, the live nodes whose children are currently being generated is called E node. Currently being generated is called E node. Note down the example. Here live node ikkada. What is live node? B is a live node. The live node who is being generated by A, that is called E node. Who has generated a live node called as E node. This is E node. E node. And here it is E node. E node. Right? Live node ని జనరేట్ చేసేది ఈ నోడ్. ఈ నోడ్ నుంచి వచ్చి నో చిల్డ్రన్, దట్ ఈస్ కాల్డ్ లైవ్ నోడ్. డెడ్ నోడ్. డెడ్ నోడ్ అంటే ఏంటి? Next, write down. It is generated. It is generated a node. Sorry, dead. It is generated node. It is a generated node. That is, dead node is a generated node that is either not to be expanded further, either not to be expanded further, not to be expanded further, or not to be expanded further, or it is one for which it is one for which all of its children have been generated. All of its children have been generated. All of children have been generated. Note on this one. Note on this. Note on this tree. A derives B comma C. Node C. It is a generated node and there is no more further extension, or it is one for which of nodes already generated. A is a node which is generated, its children, and no more further extension, and B comma C are the generated nodes, are the dead nodes. A comma B comma C are the dead nodes. Here A, B, C are the dead nodes. A, B, C are the dead nodes. Next, write down applications of backtracking. First one, n-queen problem. Second, sum of subset problem.